So to graph the secant function, it's going to be really similar to what we just did using the sine function, but this time we'll use cosine function because, to refresh your memory, the cosine is the reciprocal, or forgive me, let me say it this way. It's the same thing, but I think I might confuse you. Excuse me. Your secant function is the reciprocal of your cosine function. So we're going to do the same process. So I'm going to use these key points again, 0, pi over 2, pi, 3 pi over 2. I'm hoping you're feeling a little bit better with this, but use your unit circle until you're tested. But okay, so my cosine function at 0 will give me 1. At pi over 2, it will give me 0. At pi, -1. 3 pi over 2, 0. And then these become my coordinates. And I'm going to go to the graph and plot these coordinates. So at 0, it gives me 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and then 2 pi, when I complete that full revolution, will give me 1 again. And remember, cosine is an even function, so it's symmetrical with the y, so I don't have to do much work. I know this will be 0. I know this one will give me -1. This will give me 0, and this will give me 1. All right, I'm going to try to make this as smooth as possible and making sure they go through the coordinates. This doesn't look that smooth, but it's not terrible. So this is your cosine function. All right, so now if I want to find my secant function, choose a different color. My inputs are going to remain the same because this function still takes angles as inputs. And now remember, we're going to do the same process. Well, it's the reciprocal of all my outputs. So if I flip 1, I get 1. I flip 0, I get undefined. -1, I get -1. And if I flip 0, I get undefined. So I only have 2 nice concrete points, which are 0, 1, and pi, -1. So it's very similar to what we just did. So here's my 0, 1. And here's that pi, -1. And then once again, everywhere you hit a 0, your x-axis, it's going to be undefined because we can't divide by a 0. So we get these asymptotes. So I'll get them over here as well. And over here as well. And then the same process, right? If you were going to take the reciprocal of all of these values, they're really, really tiny, your output's really tiny, then you'll get something really large. So it's going to start skimming that asymptote. Same deal down here. Same deal down here. I could even graph part of 1 here, because my graph just cuts it off, and part of 1 here. So this blue graph is your secant graph. Now, once again, that pink, that cosine graph is not part of your secant graph. I just use it to see how I can come up with the secant function. So this looks pretty darn similar to the cosecant function, which makes sense, right? Because remember, we talked about how sine and cosine are just a horizontal shift, right? There's just a transformation that's happening, but they could be identical if I applied that horizontal shift to them. So the difference is that, you know, your asymptotes are happening at different places because your zeros are happening at different places. right, I'll see you on the next video for your last two graphs.